soon as we switch the y and the x, then what are we going to do? Solve for y. So this is an easy one. We'll times by 6, add 7, and divide by 2. Everybody okay with that? So if we're going to use proper notation, we would say F inverse. Remember, this is our inverse notation. F inverse equals 6x plus 7 divided by 2. All good? While we're here, let's do a little harder one. Let's suppose this were the original problem. How do we start this one? Same way? And then what? Rose, you got a thought? Yeah. And I'm going to go ahead and distribute when I do that. So I'm going to have 5xy plus 4x. Is that okay with everybody? Just distribute it when I multiply? All right, now here comes the piece we have to remember. What do we do now? Yeah, thank you, Rose. Get all the y's on the same side. And everything else on the other side, right? And then what? Because we're solving for y, remember? Dan?
Take out the y.
Take out the y. And then your last step? Divide. Yeah. So y equals negative 4x minus 3 over 5x minus 2.
You can never divide by a variable, right?
You're not supposed to divide by a variable unless you're absolutely sure it can't be 0.
Okay.
But when we do this, we kind of talked about this the other day. The stipulations on the domain and range of the original carry through, so I don't have to worry about it in this case. Emma?
So can we just switch the top left numerator, the first value in the numerator with the second value in the denominator, and change the sign?
I don't know. It looks like in that example, try a few more and see if that's the
It
case.
did in that one, it did in the other two we did the other day.
Then it's probably okay.
Okay.
Okay? All right, let's look at the next problem. If m of 3 is 8 and n of 8 is 2, are these guys inverses? Why or why not?
No.
No, why not?
Because the n of a should equal 3.
Exactly. If the ordered pair 3, 8 is part of m, then if they're inverses, 8, 3 will be part of n, right? If they're inverses, not 8, 2. It would have to be 8, 3. So no, they are not inverses because when you put the output of m into n, you do not get the input that you had for m. Remember, the ordered pairs must switch. Ooh, number 3. Is the inverse of p a function? Why or why not? I don't think we talked about this.
Yeah, I don't think it is. It's on the homework already.
Is the inverse a function? Now, it's not asking if that's a function. It says, is the inverse a function? What do you think? Well, let's talk about these ordered pairs. There are no repeated x's. Would you agree with that? And that tells me that's a function. What about y's? Are there any repeated y values? Do any y's happen twice? Now, an example of a y happening twice would be like your absolute value function. See how these two y's match up? Now, if this is the point, let's say 2, 3, and this is the point negative 2, 3, the inverse of this would not be a function, because when I took the inverse of this, I would have two ordered pairs that had the same x value, right? And I'm talking about the inverse. So the inverse of this is not a function because there are two y values in the original that match. And if they're y values in the original, they will be x values in the inverse. Does that make sense? Okay. Are there any y values that repeat here? No.
No.
There. Look, if you draw a horizontal line, there's two y's, right? If you drew a horizontal line here, are you ever going to get two y's? Are there ever going to be 2 points that have the same y value? No. So is the inverse of that a function?
Yeah.
Yes. Because it passes the horizontal line test. That is, there are no repeated y's. If there are no y's repeating in the original, there will be no x's repeating in the inverse. Does that make sense? This guy does not pass the horizontal line test. So although he is a function, the original is a function, his inverse would not be a function. If the original and the inverse are both functions, it's called 1-to-1. 1-to-1 means no x's repeat, no y's repeat. Every x has one y, and every y has one x. Is the squaring function 1-to-1? No. No. It is a function, but it's not 1-to-1. Why? It doesn't pass the horizontal line test. Its inverse would look like this. It is not a function. Plot at least 5 points for this set of parametric equations. All right, didn't tell me which 5 to plot, just said plot 5, so what do we do? You know this. Yeah, make up a value of t. So what happens if t is 0? What point do I get if t is 0? 1, negative 3. So one of the points I'm going to plot is 1, negative 3. Now, you don't have to plot 1, negative 3, but that's a nice easy point to plot. What if t is 1? Q, negative 2. What if t is 2? And 3? And negative 1. Now it says connect those dots. What shape are those dots? They're a nice little line. Anybody have any questions about that? They turn it over, and this is today's lesson. We've already spent some time talking about what happens in a situation like this. In fact, you had questions like that on your test. You you had to know what to do with that +2. What did we do with that +2? Move it which way? That one went up 2. If we want to move it to the left 2, what do we have to do? If we want to go left 2? In the absolute value, x + 2, and that would go left. Now, there are some other changes we're going to do. If you look down through the problems, you'll see not only do we have adds and subtracts, but we have some negatives, and we have some coefficients, some multipliers, and we even have some absolute value. So let's talk about what changes those make. I'm going to start with this weird picture . That I've given you. Alright, so that's what we're starting with. That's the given shape. Now right next to it says now we're going to graph y equals 1/2 f of x. This is f of x. This is the given. Now we're going to graph half of that. Does anybody have an idea what impact that 1/2 has?
Is it the asymptote?
What?
Does it like represent an asymptote?
No, that's a thought. No, it won't be an asymptote. Grace?
Does it make like all the curves 2 times as big?
Other way around. It actually makes them half as big. It does exactly what it says it's going to do. It takes this picture and makes it half as tall. So instead of the circle going all the way up to 2, now the circle's only going to go up to 1. It's going to be the same length. This isn't changing. Only its height is changing. So this number right here is going to make it half as tall. This number controls its height. Trevor, do you need to go to the office? Okay. Well, I know you're sick, but if you're going to be in here, you're going to be awake, okay? Otherwise, I mean, if you're fine going to the office if you need to. Now, this little thing here went down 1 before. Now it's only going to go down 1/2. And this one went up 1, so now it's only going to go up 1/2. So there you go. Putting the half out in front, putting any multiplier out in front affects the height. Remember, putting adds and subtracts did not change the size or shape at all, right? What do adds and subtracts do? Pick it up, right? Putting multipliers in now are going to change your size. Okay, now we've got the second one. Notice it's still got a half, but the half is in a different place. Actually, it makes it twice as long. When you put the multiplier on the x, it does the opposite of what it says. So it says 1/2, it really means double. Now that's consistent. Think back over here, guys. When the +2 was tacked on the end, it went up 2. But what about when the +2 was inside? It went actually back 2. It goes the opposite of what you would think. So this 1/2 is actually going to multiply by 2. So, like, see this little thing here? He's 2 units wide. Well, what's going to happen to him? He's going to become 4 units wide. still the same depth, so he's still down 1. But he's 4 units wide. And how about that guy, that mountain there? He's 2 units wide in the original, he's gonna become 4. And I'm kind of out of room here, but there it is. Now what about our circle? He's still gonna be 2 units tall, that part didn't change. Because how do I change the height? If I wanna change the height, what do I have to do? I gotta put something out here, right? That
make it
circle
8.
is gonna be 8 units wide.
We'll go up to 2, not 1.
That goes up to 2 just like the original. All right, so let's quick recap. How do I change the position of a graph? By adding or subtracting. How do I change the size of a graph? By multiplying. And depending where I multiply determines what part, horizontal or vertical change.
If it was y equals f, and then like it'd be 2x, would that shrink it to make it smaller? Okay.
Yep. In fact, it's called a horizontal shrink. Yep. Okay, now we're going to graph the absolute value of the function. Okay, so I'm going to draw my original. Now I'm going to take the absolute value of that picture. I'm going to take the absolute value of my picture. What does taking the absolute value of something do? It makes it all positive. All right. Take a look at this circle right here. Isn't it already positive? Aren't those y values already positive? So when you take the absolute value of something that's already positive, it just stays the same, right? So this part is staying the same. That part is not changing. What about this part right here? Isn't it already positive, you guys?
Yeah.
So it's staying the same. But what about this part? These guys have negative y values, don't they? What happens when I take the absolute value of something negative? It becomes positive. So that guy's just going to flip right up and become positive. There's your picture. When you take the absolute value, whatever was positive stays positive. So whatever's above the x-axis stays right where it's at. If you're below the x-axis, you simply get folded up. So let's think about our sine curve for a moment. What would happen if you took the absolute value of your sine curve? These would stay the same, right? But these guys would get folded up. So you would end up with a picture that looked like that if you took the absolute value of your sine curve. Would you agree? Uh-oh, now we've got some negatives thrown in. All right, what do you think negatives do? We kind of talked about this a little bit before. What do negatives do?
Flip it upside down.
Flip it upside down. They flip it. Negatives flip it. If the negative is out in front, as it is in the oh shoot, I erased my original. as it was in the very last problem. That negative is in a different place than this negative. Would you agree with that?
Yeah.
And so, like we're used to, those negatives are going to have different impact. But negatives flip. When the negative is out in front, as Nick said, it flips you upside down. In other words, this is going to go across the x-axis, upside down. Any guesses what a negative on the x does? Across the y-axis. And I know you're going to memorize that. I can't stop you from doing that, but it does make sense. Think about changing the sign on x. If you go from a positive x to a negative x, change the sign on x. Don't you go across the y-axis? That makes sense. All right, now, besides going upside down, what else has happened to this picture? It's moved 2 units to the left. Now, some of you are so much better at this than I am. I have to do this in 2 steps. I cannot do it in 1. Some of you can do it in 1 step. So I am going to, first of all, move myself 2 units to the left. So if I move everything over 2 units to the left, I have that picture. Would everybody agree with that? That that's my original picture, 2 units to the left. Now I'm going to turn it upside down. So everything just flips over. Nothing changes size or anything like that. It just flips over. So the green, I'll erase the black. The green is the answer to the question. And you can certainly use colored pencils if you wanted to, if you want to do it in stages like I do. Or you can erase as you go. All right, now, take the original picture, and what did he say that's going to do? Reflect across the y-axis. So that means anything that was on the right is now on the left, and vice versa. So there is the reflection across the y-axis. That's this part right here. I'm not done yet, but that's that part right there. You with me? Now what do I still need to do?
Move it over.
Move it up 1. There we go. You okay with that? Okay, there's one more thing. I was looking on my sheet and I don't see one. So there's one more thing I need to talk to you about, and then we'll do some more practice there. But let's keep the same shape, the same original shape. Actually, no, let me give you a different shape. I'm going to practice another. So somewhere on your paper, on another sheet of paper or something, draw this shape. now we're going to sketch that, which we've already practiced, so maybe you'll remember how to do that, and this. See the difference? I'm taking absolute value of both of them, but it's a little bit different. Here, Taylor, you cannot possibly be bored. This is exciting stuff. How do I do the absolute value of the whole function? Remember?
Everything's positive.
Which means what in terms of the picture?
The dip, I guess, needs to be above.
Exactly. So everything that's already positive is going to stay positive. So this part's not changing. And this part's not changing, but this part's coming up. Would everybody be okay with that? Okay. Now, this is a little bit trickier. This says that as long as x is positive, nothing's going to change. So that side of the axis, the right side of the picture, stays exactly as it is. Now this says that if you put in a negative x, you're going to get the same output as you did if you put in a positive x. If you put -2 in here, it's the same as putting in a 2. Would you agree with that? So in other words, all of this side of the picture is irrelevant now, because the x values are going to be duplicated. When they're negative, you're going to get exactly the same result as when they were positive. That's the picture. So when I put in positive x values, this is what I got out. If I'm taking the absolute value, then I'm going to get exactly the same picture when I put in negative x values. Think about that. This is the picture I get when I put in positive x's. If I'm taking the absolute value of x, won't I get exactly the same values if I put in negative x's? That's why I get exactly the same picture for positive x's and negative x's. Now, what happens to all this? It's gone. Gone. Irrelevant. Gone. Whatever your positive x's are will be repeated for your negative x's, because you're taking the absolute value of x.
This is just a reflection.
Yep. Of just the positive ones. The positive x-axis just gets reflected over, because the positive x's and the negative x's have exactly the same values. Okay? All right, take a minute at your table, or at your groups there, and do the next page. Just the front for now, just the front of the next page. See if you can come up with those pictures. We'll put them up here on the board. Use the new shape up there at the top of the page.
Did we not?
Yeah, we did, but there wasn't a negative in front. So what we have to do is, so we have to go across
Just
these.
so you close across, yeah.
So it'd be,
There's not enough room for one of them, should we just like make a new?
Yeah. Or you could change your scale. You know, instead of each hash mark being 1, you could make each hash mark 2. Whatever's easiest for you.
so Dan, does yours look like that?
They make sure mine looks
flip it across the y.
No, you flip it across the y-axis. So just
Yeah, mine looks like 7.
Yeah. I see.
Yeah.
X-axis is when it's outside.
Yeah. Literally opposite Y. Yeah, it's in twice.
Is that what you look like?
Yeah.
Yeah, so it's twice as Oh, yeah, no. No, that's right.
Anybody ready to put one on the board?
And this one was like the one we just did, right? Wait. Oh, the whole thing's inside it, so. Okay, so flip it across the x-axis. So it has to be.
So first, you would just do
Well, I'm gonna flip it
okay.
first and then everything.
Should do that. Should do that.
And then let's see.
Vincent, you guys got these done? You wanna put one up for me?
Sure.
Nick, you wanna put one up? Emma, put one up? Matt, you done?
Yeah.
Put one up. Victoria, put one up.
So I first flipped it. And
How
then
does
it's
Joe?
move it to the right. So then
Anybody get the equation?
Is the equation based off the original?
Uh-huh. Oh no, those are board markers. Is there an extra one? If it works, but it won't hurt us to have a couple extras. upside down.
Y, and then the minus 1.
Is it in the parentheses or out?
Inside.
It's the right one.
Right, okay.
All right, let's see how we did here. How about this first one, guys? Are you, let's vote. Are we in agreement? This is what this looks like? Yes. Yes, because what does that negative do? Flips you across the y-axis. So what was on the left is now on the right and vice versa. Perfect. How about the second one? How do you feel about that?
Yeah, pretty confident.
Because that plus one just took the original picture and lifted it up one. Beautiful. Uh-oh, what happened here? That's the original picture, except everything is twice as long. So instead of on the original, this little guy was over just 1 unit, now he's over 2. That V thing is 4 units wide. And then the bar was 1, now he's 2. And the V was 1, but now he is 2. I think that's beautifully done. All right, what about the first one over there? Let's get this on the video. What about, no. What about that right there? What do you think? The part that was below the x-axis has been flipped up. Beautiful. What happened here? The last graph, what happened? Everything went right 1, and then it got turned upside, no. Yeah, then it got turned upside down? Is that what happened? I don't have my original with me. And nobody did the equation. Well, I don't know. Go ahead, Hannah. Go put it up there.
Oh, I don't know. Try that.
Well, the worst we can do is laugh, right? Go ahead. And we won't laugh, so don't worry. Okay, she says that green marker is kind of hard to read. She says 3 f of x. Is it the same as the original in terms of position? Which means nothing has been added or subtracted? The only thing that happened was it got 3 times as tall? Oh, no. If it's going tall, then the coefficient's out in front, and it's exactly what you say it's going to be. So it's 3 times as tall. 3f of x. Nothing else changed on that picture, right? Good job.